In this video, we're going to look at quadratic inequalities. And again, it's quadratic because we have the x squared term is the highest power on any of the variables. So we start off, first of all, we call this our test box. Okay, and you'll see at the end of the question why we call this our test box. Okay, so we solve this quadratic trinomial first. Now, we can't solve this using normal factorization, so we actually solve it using the minus b formula. So it's minus b plus or minus the square root of b squared minus 4ac all over 2a. And of course, you don't need to memorize that, that's going to be given to you. But what you need to be able to do is identify what the a is, what the b is, and what the c is. So a in this case is 2, b is minus 7, and c is minus 3. And then we sub these values into our minus b formula. So we're going to have minus 7 plus or minus the square root of minus 7 squared minus 4 times 2 times minus 3 all over 2 times 2. Now, when you put that into your calculator, the two possible solutions that you get for x is that x equals 7 minus the square root of 73 over 4, or that x equals 7 plus the square root of 73 over 4. Now, to be able to solve this question, what we'll do is we change these into decimal form. So this is, I suppose, it's approximately, when you round it, minus 0.39. And then this one here is approximately 3.89. Okay, so these are the two possible values that will work for this particular quadratic trinomial. But as it's an inequality, we have a solution set. So that means we have a number of different values that will actually work for this particular quadratic trinomial, because we're looking for this to be greater or equal to 0. Okay, not just equal to 0. So these would be the values when it's just equal to 0, but as it's an inequality, it's greater or equal to 0. So we're looking for a solution set. So how do we work out what that solution set is? So what we do is we test regions. Okay, so we take these values, so we take x equals minus 0.39 and we take x equals 3.89. And what we do is, right, we say, okay, let's test it for all values that are going to be less than minus 0.39. Then we test for all values in between minus 0.39 and 3.89. And then our last region is we test for all the values greater than 3.89. Now, we pick any values. So we have 3 regions. So we have this region, this middle region, and this upper region. So down here, we're looking for a value that's less than minus 0.39. Okay, so if we just pick x equals minus 1. So pick an easy value for yourself. Okay, don't be picking decimals or fractions. So we take the x equals minus 1 and we sub it into our test box. Okay, into this equation up here. And that's why we call this the test box. Okay, so we sub the minus 1 into our equation up here. So we have 2 bracket minus 1 squared minus 7 bracket minus 1 minus 3, and we test to see, is this value here greater than minus 1? And when we put this into our calculator, we end up with 6. 6 is greater than 0. Okay, so 6 is greater than 0. So we'd say then our solution set will lie in this direction. So the values that are less than minus 0.39 will work for this particular quadratic trinomial inequality. So all the values, if you test for minus 2, minus 3, minus a half, any values will work in this particular quadratic trinomial. So therefore then we would say that the values for x will be less than or equal to minus 0.39. The next region we test is this middle region. So we test for values in between minus 0.39 and 3.89. The easiest value to pick here is going to be 0, okay, because 0 lies in between here. And again, we sub the value for 0 into our test box. So we have 2 bracket 0 squared minus 7 times 0 minus 3. And we check to see if that's greater than 0. Now, when you pop this into the calculator, you're going to get minus 3. Minus 3 is not greater than 2. So our solution set will not lie in between these two values. So no value in between minus 0.39 and 3.89 will work for this particular quadratic trinomial inequality. So the last region then that we need to test is this region here. So we test for values that are greater than 3.89. Again, you can pick any value, but pick the next one, I suppose, and the smaller the number, the easier for you. So we sub the 4 then into our original equation. So we have 2 times 4 squared minus 7 times 4 minus 3. And we want to test then, is this greater than 0? When you put that into your calculator, you end up getting 1. Now, 1 is greater than 0. So therefore we say our solution set will lie in this particular region. So we would say then that x, the value for x, will be greater or equal to 3.89. So if we take both of these and we write it as one inequality, okay, so one solution set. So we're saying that x is less than or equal to minus 0.39 and it's greater or equal to 3.89. Now, if you were asked to plot that on a number line, then how would it look? So let's draw a number line. So we have 0, minus 1, minus 2, minus 3, and so on. 1, 2, 3, 4, and so on. If you remember back to junior cert, or means roads. Okay, so when you're doing it on a number line, it's going to be everything's going to be shaded in because we're talking about every value, not just the whole numbers. So if we look at our solution set, x is greater than or equal to 3.89. So 3.89 is going to be somewhere around here. Okay, so we circle that value, okay, because the 3.89 is included, and it's all values then greater than that, going on then for infinity. Okay, then on the other side, it's all values less than minus 0.39. So minus 0.39 is about here, and again it's a closed circle because minus 0.39 is included, and then it's going to be all values going in this direction, and again for infinity. So every single value less than or equal to minus 0.39 will work for this particular quadratic trinomial, and all values greater than or equal to 3.89 will work for this particular quadratic trinomial.